understand average product and marginal product in order to understand how firms make output decisions, which ultimately is going to determine how much welfare emerges from markets and is redistributed to firms and individuals in society, and the consequences of market failures. So this is maybe the most boring concept in this entire class, but it's one of the most important concepts in this entire class, because what drives the shape of this average and marginal product curve here is technology, right? It's our ability to combine inputs and convert them into outputs. That will ultimately translate into the shape of our cost curves, which will tell us how much firms produce. So it's important, trust me. If you don't care about it, I'll test you on it on the midterm. So you have to think it's important, okay? So this slide here, I'm sorry, I screwed up. I over Control C, Control V here. What this was the GPA grade in 106 connection. So I explained this to you, the grade in the class, if it's above your GPA rises, and the other way around works too. Okay. So this is the summary here. Average product of labor and marginal product of labor curves in words. The average product of labor, it first rises and then falls. And I'm going to show you in a second that the average product of labor is the slope of a line from the origin to the total product curve. Why that is, you're going to learn in 1 second, but it's going to come in really conveniently. The marginal product of labor rises and then falls. We saw it has a nice peak. It cuts the average product curve at its peak. And I'm going to show you in a second that it is the slope of the total product curve. All right? So what you should do right now is take a sip of your coffee if you brought one in. You're not supposed to in these rooms, but cheers. Maybe have a cereal bar, because I'm about to draw one of the crazier pictures in this class, and I'm going to do it on the whiteboard. All right? So what I'm going to do is I'm going to use this very environmentally friendly substance called chalk, and I'm going to draw a graph on the whiteboard. On the y-axis, I'm going to put output. On the x-axis, I'm going to put labor. So I'm going to teach you how to draw the total product and corresponding average and marginal product curve without having a table, by just drawing a total product curve and then from it getting straight to the marginal product and average product curve. Why do you need this? Because in order to answer the questions we're going to be after answering, you're going to have to be able to draw this in your sleep. So if somebody wakes you the night before the midterm and says average product, marginal product, you can draw me this and go back to sleep, right? So let's look at what we're talking about. So first thing I want to draw is the total product curve. And for our friends abroad who are listening, I'm going to draw this again digitally in a second, but I just want to draw this twice. So this is the non-online bonus you're getting right now. So the total product curve, in some sense, is like two pieces of a U, okay? So you draw the right side of a U, and then you draw an inverse U on top of it, right? So there's a point here, that's the inflection point. And there's a point here where the curve reaches its peak. Okay, what I want to do now is I want to derive the average product. In order to derive the average product, I usually have a bright pink neon shoelace, which I use in office hours, but somebody borrowed it and didn't bring it back. So we're going to have to use this one, which is not very visible, but, well, maybe. Hold on. Those are very high-tech shoelaces. They don't absorb chalk. Okay, what I want to do is the following. I want to figure out the average product from this curve. So pick any point on this total product curve. Point A for Alfhammer. I want to figure out what is the average product at A. Well, the average product is always Q divided by L. Okay, do I know what Q is at that level? Yeah, right, I just go across. That tells me the level of output. Do I know what L is? Yeah, I just go right down here and I get L. So I could just divide Q by L, and that gets me the average product. Great. Boring. Let me try something different. Let me draw this line from the origin, okay? I'm going to take my shoelace, I'm going to pin it to the origin, and I'm going to connect it straight to point A right here. Now I've got a line from the origin to point A. The slope of this line is, well, rise. What's rise? Origin to Q, right? So this distance right here, that's rise. What's its run? 0 to L. So the slope of this line is Q minus 0, which is rise, over L minus 0, which is run. Q over L. So what's the slope of this line? At least half the class said it. It's the average product of labor. So if you want to figure out what the average product of labor is, right, you could just, don't come in with Velcro shoes or these fancy slip-on shoes. Boots are useless too. You know, bring out some Doc Martens, long shoelaces. And at any point, if you want to figure out the average product, right, you will just connect the origin to the total product curve, and that slope of that brown line right here tells you the average product. I should have worn Doc Martens. These shoelaces are too short. I'm going to need to engineer a longer shoelace here in order to make my next point. Come on. Here we go. I used to sail. I know a lot of knots. All right, show off. So let's do this, okay? Watch with me the following movie. It is the most analog movie you will ever see in your entire life. Pixar would be horrified. What I want you to do is just for a second, focus on the slope of this line and see what happens to it as I trace along the total, whoa, product curve. Let's do that again. When you think it's reached its peak, say beep, okay? Yep, you got it. All right. So somewhere here, right, if we go from the origin to here, come on, roughly here, right? So I'm just going to go a little bit further, where the line from the origin is tangent. So if I took a stick and I sort of leaned it until it sort of falls onto the total product curve right here, that's when average product goes from being increasing to decreasing. Let's just make sure one more time. Ready? Increasing, beep, decreasing. Okay, so now I have a quantity here that tells me something. It tells me that at this quantity here, average product goes from increasing to decreasing. So I can figure out using my shoelace, right, and my total product curve, qualitatively, where my average product curve goes from increasing to decreasing, and it's at that point where a line straight from the origin is tangent to my total product curve. So I've got my average product curve figured out. Now, I'm going to get fancy. Let's figure out marginal product. We're going to do something similar here. Okay, this is my total product curve. What does the marginal product tell me? Well, the marginal product tells me the change in output from increasing labor by one more unit. Let's do that. In comes my handy to-do list. Yes, it's analog. It's the best to-do list in the world. Moleskine, little checklist. So, and it's visible from the back row. So what I want to do is I'm going to figure out two quantities, 3 and 4 of labor, and I want to figure out what the change in output is by going from 3 to 4. Right? We actually know the answer to that question. So from 3 to 4, the marginal product is 20. Okay, so you go from 36 to 56. So what this marginal product tells me is I go from 3 to 4, I add one more unit of labor, my output goes from 36 to 56. You could do this anywhere on the curve. Well, graphically, is there another way to show this? Well, another way to show this is it's rise over run, right? How much does quantity go up by over how much labor changes by? So what is that? Well, it's rise over run. What's the slope of this line right here? It's rise, right? 36 to 56 if I connect these two dots. It's the slope of this edge right here over run. So the slope connecting any 2 points on the marginal product curve, right, tells me the marginal product of labor. Whoa, Max, that was a lot. Right, think of this when you were first explained what a partial derivative is, or the slope of a line was, right? The slope on a nonlinear line changes along the line. So you're just looking at any 2 points on a given function. What is the slope of that line? And that's just you connect those 2 dots, those 2 points on the line by a straight line, and the slope of that line gives you the derivative of that line. So what we can do is, let's go along the total product curve, and let's see what happens to the slope of the edge of my notebook here, okay? So as I go up, does it get steeper? Yes. And then something happens right about here, where it gets flatter. Now it's flat, it's 0, and it becomes negative. Let's do that again, right? See, the thing starts tilting towards the right until we get somewhere here, and then becomes flatter, becomes perfectly flat here, and then goes negative. So there are 3 points where something happens. Something happens here, and something happens here, right? Here, MPL goes from positive to negative. Ignore that. MPL goes from increasing to decreasing. And up here, MPL goes from positive to negative. So somewhere to the left of where my average product of labor reaches its maximum, the marginal product of labor goes from increasing to decreasing, and somewhere to the right of where my average product of labor reaches its maximum, marginal product of labor actually goes negative. So we have 3 points here. We have this one, right? So that's the first one. And then we have this point here. So to the left of this thick line, marginal product was increasing. To the right of this line, marginal product is decreasing. To the left of this line, marginal product is positive. To the right of this line, marginal product is negative. All right, so now we have everything we need in order to draw it. So my marginal product and average product are increasing to the left of this line, reaches its peak right here, then it goes to decreasing, and we know that it cuts average product at its maximum, and it's decreasing in positive until we get to the peak up here and then goes negative. So using nothing but a shoelace and an old, Moleskine book, we can figure out from a simple total product curve what the corresponding marginal product and average product curves roughly look like. We're not going to get it numerically exactly right. You need a spreadsheet for that. But qualitatively speaking, to the left of the inflection point right here, where the U has stacked on top of it an inverse U right here, to the left marginal product goes is increasing, to the right it's decreasing. At the point where we have the top of the total product curve, at labor amounts lower than that, marginal product of labor is positive, it points to the right of it, it's negative. So we've really got everything we need in order to draw these things qualitatively. So let's do that. So if I draw this on my digital magic tablet here, so I'm going to zoom in a little. Right, you can draw it any way you want. But what you need to do is you need to draw a U that looks like this, and then put an inverse U on top. So you already know the points that matter are the inflection point and the peak point. Right? Plus you're going to need one more quantity here, which is the quantity where the line from the origin is tangent to the total product curve, which if you draw it right looks something like this here. So we have 3 points that matter. This drawing doesn't correspond to the numbers I gave you earlier, right? So if you're sitting at home trying to figure out why this curve looks different than one we drew earlier, I'm just sketching one now, okay? But what we've got now is 3 quantities here. So to the right of this curve here, of this point, MPL is negative. To the left, MPL is positive. To the right of this point here, APL is decreasing. And to the left of this line here, APL is increasing. And then we've got a last one. We've got red, green. Let's use black. So I got that, and we need the marginal product still. To the left of this one here, MPL is increasing. To the right here, MPL is decreasing. Right? Now we've got everything we need to know in order to draw our marginal and average product curves. So I'm just going to zoom back out, and I'm going to extend these lines to the graph below. That's terrible. Okay, these are the 3 ones we need. Let's start with the average product of labor. The average product of labor to the left of this curve is increasing. To the right, it's decreasing. So that's the average product of labor. Now we're going to draw our marginal product of labor, which is increasing to this point. Then the way I've drawn it, it's got to crash pretty hard, decreasing here, equal to the top of the average product of labor curve at its maximum, and then goes negative right here. That's a lot. I realize this. And even though Max is talking through it, and it's incredibly boring, it's the worst kind of boring. It's boring and it's hard. All right? So what I'd like you to do is, if you don't listen to me on YouTube, that's totally fine. But this one right here, just fast forward to the YouTube point where this is happening and try drawing this 5 or 6 times so you feel comfortable without hearing me talk you through it, that you know how to draw this one, right? How to get from a total product curve that's half a U, the right side of a U, and an inverse U on top, you get to the marginal product and the average product curve. We're going to stop drawing the top picture very soon because everything we need to know about behavior comes from these 2 curves right here. The total product curve is only for CEOs. This one is what real people look at in order to make decisions. It's the average and marginal product curve. So let me use my last 3 minutes to check your intuition here. Right? What about a linear total product curve? What if you don't have this sort of U inverse U total product curve, but what if you have a potato salad production function? Where doubling inputs always doubles output. Right? It's the potato salad production function. You double the amount of potatoes and you double the amount of mayonnaise, you get twice the amount of potato salad. So a linear total product curve looks, surprise, surprise, linear. Okay? So this is total product. So this line here goes, let's pick a point, goes through 5 and 40, right? It's a straight line. So the average product for each worker, right, is at this point A right here. Average product is, well, 40 over 5, it's 8. Right? At 10, it is 80 over 10, it's 8. So for a total product curve that is linear, the average product of production is always the same. It's constant, right? Because if you put twice the amount of input, you get twice the output, or you get this in sort of constant proportions. The average product curve here is actually flat. But Max, what about the shoelace business? You told me about the shoelaces. Well, let's use our shoelace, right? Shoelace is the slope. The slope, average product is the slope of the total product curve connecting any point on my total product curve to the origin. So does the slope of this thing ever change? No. As I go up the total product curve, right, the slope of the shoelace, which is my average product, is always the same. So the shoelace trick works here. Average product for a linear total product curve is constant. What about marginal product? Right? Marginal product here is going to be very similar. Right? So what's marginal product going to be here? It's also going to be 8. Right? So if the average worker has an output of 8, each additional worker always produces 8 units. If he were to produce more or less than that, the average product would change. So the marginal product here is exactly the same. So let's just use our shoelace one last time. Right? Does it change ever? As I use my slope, my 2 points, any 2 points that are exactly one worker apart up the total product curve, the slope never changes. So the marginal product of labor is equal to the average product of labor and exactly 8. All right? On that very depressing note, this is one of the most boring lectures of the year, by the way. We're going to get more excited soon. But this is where the midterm material ends. All right? I owe you an announcement for a review session. I will see you on Thursday and then again on Tuesday at the exam. Have a very nice week.